Okay, on this one, we have the limit as x approaches pi halves from the negative side of this. And just remember that secant is 1 over cosine, tangent is sine over cosine. And if we plug in the limit, pi halves, it's up here. So our cosine is 1. Or, oops, I have that backwards. Cosine is 0, sine is 1. So if we plug in a 0 here, we're going to get 1 over 0, which when we're thinking of limits, that goes to infinity. So this one's going to go to infinity. If we plug it in here, since cosine's on the bottom again, it's going to be 1 over 0, which also goes to infinity. So we have infinity minus infinity. Now, that's not a L'Hopital indeterminate form. So what we're going to do is we're going to replace these with these and turn it into a quotient to see if we still get infinity over infinity or 0 over 0. So if I do 1 over cosine x minus sine x over cosine x, we can just combine those. They already have common denominators. Okay, and so we can take the limit, and this is the exact same as this. Now if we do, now if we plug it in, we're going to get 1 minus 1 over 0, and so that's going to be 0 over 0 indeterminate form. And so what we need to do is use L'Hopital's rule and take the derivative of the top and the derivative of the bottom. So the derivative of the top, 1 just goes away. Negative sine, so sine just goes to cosine, so negative sine goes to negative cosine. And then cosine goes to negative sine. Okay, so those negatives are going to cancel. And we take the limit as the top and the limit. And so if we plug that in, we get a 0 on top. If we plug it in, we get a 1 on bottom. And so overall, the limit is 0 once again, meaning that this limit is equal to 0.